Hello, this is Chuck Ridgway. It's Tuesday. It's time for another technical topic. Now, we did pre-record our topic for today, which is updated OCS bootloader recovery tools. Now, about a year ago, we covered this topic with the tools we had available at the time, but we've made some improvements, so we thought it would make sense to revisit the topic, showing you the latest and the greatest. And because I am flying solo today in a pre-recorded fashion, I don't have Casey Gardner or Nate Beachy or any of my other colleagues with me today. But rest assured, if you're watching this live, we will be answering questions live if you type those in the chat section. If you're watching it on replay, give us your questions in the comment section and we'll get those answered just as soon as we can. Okay, let's go ahead and get started. Here's the breakdown of our topic for today. First, we're going to do a quick review on what is OCS firmware. We're going to talk about when we would use these bootloader recovery tools. We're going to walk you through the recovery procedure and we're going to demonstrate it. All right, let's dive right in. So what is OCS firmware? Well, OCS firmware is the code that runs on the OCS hardware, and it's the part of the code that is created by Horner engineers. It provides the OCS product with its functionality, with all of its features. Now, the firmware is what actually executes the application program, the CSP file, or in some cases the PGM file, that the customer application engineer loads onto the OCS. So it actually executes that code. Now there's actually multiple elements to OCS firmware. First of all, there is the operating system. All OCS units use an operating system, and it does vary depending on which OCS series you're using. Whether you're using a micro OCS family, whether you're using an XL series family. They use different operating systems. Now, what we call the firmware is actually just one of the three portions of code. And again, that's the code that's created by the Horner engineers. And then in addition to the operating system and the firmware, there's also either FPGA or CPLD code. What is that? Well, that is special code that runs in a high-speed coprocessor chip that handles all the high-speed inputs and the high-speed outputs. That's so all those signals can be handled outside of the main processor, so they're not dependent on the main scan rate of the processor for their execution. Now, depending on the OCS product you have, you're going to potentially be using a slightly different method for updating its firmware. If you're using one of our micro OCS products or the XLE and XLT, then you're probably going to be using your USB cable connected to your computer, and you're probably going to be using Cscape to update the firmware in that controller. Now, if you're using an XL series product, an XL Plus, or an RCC, and an X5, X5 is kind of a special exception, then you're going to be using a file set downloaded from the web that is loaded onto the OCS from either MicroSD or USB. And then if you're using an RCC, you've got to use a bootable MicroSD in order to update the firmware on that unit. Remember, an RCC is an OCS that doesn't have a screen. Okay, so it doesn't have a user interface that can walk the user through the firmware update process. So therefore, you need to use a bootable MicroSD if you're going to be updating the firmware on one of those RCC units. Now, what happens if a firmware update goes wrong? It is possible for that to happen. Okay, so you go to do a firmware update on an XL series unit, and for whatever reason, it does not complete successfully. Maybe you had a power cycle at the wrong time, maybe you had another problem. And now, let's say, because of this, you've got a XL series OCS that just won't boot. So in this case, in this scenario, you're going to need to use a bootable MicroSD in order to recover from this eventuality. And recently, we've released a new and improved utility for creating those bootable microSDs. That's why we're sharing that with you today as today's topic. So in summary, when am I going to use a bootable microSD? Well, you only really need to use it when a firmware update goes bad on an XL series model and you need to recover. When a firmware update goes bad on an X5 and you need to recover. Or if you're just doing a normal firmware update on an RCC, because it doesn't feature a built-in screen or user interface, you're going to need to create a bootable microSD in that case as well. Let's walk through the XL series recovery procedure, and then we'll demonstrate it for you at the end. So the first step is you're going to need a microSD card. Now it's easiest if you get a microSD card that is 32 gigabytes or smaller. And today you should be able to find pretty easily 16 gigabyte or 32 gigabyte microSDs available on the market. Now, why do we want to get cards of that size? Well, those cards, the ones that are 32 gigabytes or smaller, they come pre-configured with FAT32. The larger ones, the ones larger than that, they come with a file format called exFAT. And we don't want to use exFAT. We need to use FAT32. So if you do have a larger card, you're going to have to format it in FAT32 using a special utility on your computer before you can kind of start the process of getting into this recovery procedure. But if you've got a 32 gigabyte card or smaller, it comes pre-configured with FAT32 and you're good to go. So once you've acquired your card, you need to download the OCS Bootload Creator. That's the new utility that we've just released here in May of 2022. So you either need to download that from the Horner website or acquire it from one of your tech support application engineers. Once you've done that, you're going to install it on your Windows PC. It installs just like any other computer program, just like Cscape installs. It's an executable file, and it works just fine on Windows 7, Windows 10, and Windows 11. So once again, you're going to install that executable on your computer. Now, once you've done that, once you've done the install, you're going to insert your microSD card in your PC. Okay, and it's going to mount as a drive on your PC. Then you're going to go ahead and run the OCS Bootload Creator utility that you just installed. Now, in the process of running that, you're going to need to select the controller model you're using. You're also going to need to select either 2-channel mode or 4-channel mode for high-speed counting. Now, for years and years, only 2-channel mode for high-speed counting was available with the XL series models. A few years ago, we made 4-channel mode also available, but it requires different FPGA code. So that's why you need to select that. Now, if you're not sure which one you need to select, then by default, just select 2-channel mode. All right? And then the final thing you have to select is the drive letter, the microSD drive letter for the microSD card you just installed. In my demo I'm going to show you in a few minutes, it was drive D. Your results may vary. Now, once you've run that utility, it's created a bootable disk for you, or a bootable drive for you. Next, you're going to take that bootable drive out of your PC and install it on your OCS. Now, there's one of two things is going to happen next. If you have an OCS with a dip switch for controlling bootable drives, then you're going to need to flip that dip switch and then apply power with the microSD card installed, the one that's bootable. If you have an OCS model that has a push button for booting from microSD, then you're going to need to hold in that push button while you apply power to the unit and then release it. Next, the OCS is going to boot. So before, remember, it wasn't booting. That's why we're going through this recovery procedure. But the OCS will go ahead and boot, and it's going to prompt you to install the bootloader in the local flash memory of the OCS. Because remember, we don't just want to invariably be booting from microSD. That wouldn't work. Then once that process completes, if it was a dip switch that we used to boot from MicroSD, we're going to flip it back to its default position and power cycle. And then once we do that, we should see pretty much a normal boot with some expected errors. Errors because we don't have a program installed, and errors because we have abnormal power down causing a battery type message. But that is just it's not a real battery failure. It's just a battery message that will pop up in that situation. And at that point, we're fully recovered. And remember, I'm going to demonstrate this for you here in a minute. Okay, now how do I know if the OCS I'm using has a dip switch for prompting the unit to boot from MicroSD, or if it has a push button? Well, let's take a look at that right now. The X5, the XL4, and the XL7, those three products all have dip switches. So on the X5 and the XL4, they only have one dip switch. And it is operator number 3 of the one dip switch that is used to boot from MicroSD. Now on the XL7, there is a dip switch on the side and a dip switch on the back. The dip switch on the back is SW1, and again, it's operator number 3 that basically prompts the unit to boot from MicroSD. If you've got an RCC, an EXL6, an EXLW, or an EXL10, those units have push buttons that are recessed, that are located near the mini USB port that's used for programming. And I've shown you there the EXLW. The rest of them look the same. Of course, the RCC, it looks different, but its button is clearly labeled on the front of the unit. All right, let's go ahead and demonstrate this for you now. Okay, I'm going to go ahead and simulate here a firmware update gone bad. So I have my XL4 controller running here, and I want to do a firmware update. I've already downloaded the XL4 file set for the firmware version that I want to download, and I've put it on a microSD card and installed that microSD card in the XL4. So now I press and hold the system button, and then in my application I hadn't locked this out. So ultimately, the boot installer screen comes up. I can press install bootloader. It says, are you sure? Yes, and it starts the process of doing the firmware update. Now let's say I had an unexpected power cycle, okay? I had a loose wire, maybe, power at my facility went out at exactly the wrong time. So now I'm in a situation where I'm not any longer going to be able to boot, more than likely. So let's see here. So I just powered the unit up again, and in the case of the XL4 here, we're getting nothing but a blank screen. So I'm going to have to recover from this somehow. I'm going to press and hold the system key just to see if that helps me any. But it's doing absolutely nothing. Okay, so I've got a situation here where I've got an XL4 which won't boot, and I need to recover from that. Okay, now that we've installed our utility, let's go ahead and use it to create a recovery disk for the XL4. So I'm going to go ahead and run it using the shortcut on the desktop. What we have here is the utility running. Now I have installed on my computer, or I have plugged in on my computer, a MicroSD card, which is showing up as drive D. And this is a 32 gigabyte SanDisk card is what I've got here. And what we want to do is we want to create a recovery, a bootable microSD for recovery purposes for the XL4. So this is pretty straightforward. So all we have to do is select our controller. It's going to be XL4 in this case for the C-SCAN network. Now, in my application, I'm going to just be not requiring 4-channel high-speed counter mode. So the standard 2-channel high-speed counter mode is fine. Okay, that's the default. If for whatever reason in your application you need 4 channels of high-speed counting, then of course your application will need to be configured for that. And then my MicroSD is indeed plugged into drive letter D. And let's just hit go and watch what happens. Now we are potentially, when it's done, we are going to get some errors. Now why would we get errors if everything works properly? Well, in general, what we're going to see is we're creating a bootable MicroSD in an operating system that is not Windows. So Windows is not going to recognize at least part of the drive that gets created. There'll be a partition that gets created that Windows will not recognize. So at some point after we've successfully gone through this process, we're going to see an error message from Windows that says something like, you know, hey, this drive is not recognized, or you need to format this drive, that sort of thing. But ultimately, you are also going to see success messages from the utility telling you that everything worked. So let's let it complete and let's see what happens. Okay, we're doing this in real time. I didn't speed it up at all. Doesn't take all that long to create the bootable drive. Okay, we're getting close to the end here. Let's see what happens. Okay, there's my first Windows error message. It says, hey, there's a drive E here that I can't access. That's okay. That's a partition it doesn't recognize. But we also get a success message here from our bootloader utility that tells us everything worked properly. So now we can go ahead and eject the drive and then use it in our OCS controller to recover from our failed firmware update. Okay, now let's use this bootable microSD card that we just created with the utility to recover this XL4. So I've already installed the microSD card that I just created that's bootable, but with an XL4 what I have to do is I have to flip dip switch number 3 over away from its default position. Okay, and there's power not applied to this unit right now. All right, now I'm going to go ahead and apply power. So I have the bootable microSD card installed, and I have dip switch 3 on the XL4 flipped over to its non-default position, and I've applied power. Look, we've got some booting going on. That's good. Okay, I've got some errors, but that's okay. At least I'm booting. Now I can go ahead and complete the install bootloader process, because remember, I got to get this firmware and bootloader set over onto the XL4 in its native memory and not just boot from microSD every time, which is obviously not what I want to do. So we're going to watch this guy in real time. It's going to take us about a minute to go ahead and do the update. Now there's a very important step that we don't want to forget here at the end, and that is once we've completed this process that we're watching right here, what we're going to need to do is return dip switch number 3 to its default position before we reboot again, because otherwise it's going to be expecting to boot from microSD, which is not what we want, and then it won't boot and we'll wonder what's going on. Well, what's going on, if we forget, is that the dip switch will be in its wrong position. So again, when this process is complete, I'm going to go ahead and move dip switch number 3 to its default position and then power cycle. Okay, you can see we're complete here. Let's go ahead and move dip switch number 3 back. We don't have to remove power to do that. Okay, now we're going to go ahead and reboot the controller. Now we're going to see some errors. That's okay. The errors we're going to see are going to be related to 2 things. 1, there's no program running in this guy. And 2, because we didn't shut down in what you would call a controlled fashion, we might see a battery error. Okay, so we'll see what errors we get here. Okay, yep, we've got both the types of errors we expect to see when we have no program, and we also got a battery error there. But if I do another power cycle, okay, then what I should get rid of is the battery error. Okay, so I'll still see no program to display, but you won't see the flash of any kind of battery error. If you do, on the second power cycle, it means you truly do have a battery problem. Yep, see, no battery error there. Everything's good. So we've successfully recovered, and we're ready to download our program from Seascape or load it from MicroSD, whatever we plan to do, and we fully recovered from our problem with the firmware update. Okay, so that's the demonstration, and that's the material I wanted to cover for you today. Once again, if you're watching this live, give us your questions quickly on chat. If you're watching it on replay, give us your questions in the comment section. Okay, a couple things before we close. Remember, we're here every Tuesday at 2 o'clock with another technical topic. We're usually fully live, but occasionally we'll pre-record our video like today. But we're always standing by on Tuesdays at 2 o'clock to answer your questions live. Also, next week, we think we've got a good topic for you, and that is OCS user security. So that's not the security that's tied to your application file on Seascape. That's the security that's used by machine users to log into the OCS if you choose to take advantage of that feature. And we'll be covering that next week. A couple other quick notes. If you haven't done so already, don't hesitate to subscribe to our channel. If you choose notifications, you'll be notified every time we go live or every time we post another video. So, thanks for joining us, and we'll see you again next week.